Hello everyone, myself Amrita NB. I'm pursuing my bachelor's in electronics and communication from Bangalore Institute of Technology. My seminar topic for the subject data structures and algorithms using C is recursion. In this video, we are basically going to be discuss about what is recursion, what are the types of recursion, what is the need for recursion, the steps which we need to follow while writing a recursive program along with a simple example. What is recursion? Recursion is a process in which the function calls itself directly or indirectly. This is called as recursion, and the corresponding function is called as a recursive function. A recursive algorithm is the one which takes one step forward towards the solution, that is the base case, and then calls repetitively in order to further move towards the base case. It reaches towards the solution and then moves forward towards the base case. Since the function may call itself, this process might continue forever. So it is essential for us to provide a base case to terminate the process of recursion. So this is a basic structure of how a recursive program looks like. We have a recursive function, then it checks for the condition, that is a base condition. If it is encountered, then it will terminate the execution of the loop and basically backtrack towards the final solution. Or else, if the base condition is not yet encountered, then a set of recursive statements are seen which moves forward towards the solution, and also it makes a recursive call to the function itself again. When we use the word recursive, it also means to say it is iterative. Then a thought might come to our mind, why not use loop for looping statements and while looping statements? Why to use recursion? It's such a complex process. We have to understand the logic behind it, we have to implement the base case and everything. But what is actual use of recursion? Recursion basically helps in building logic and also helps in solving complex problems in simpler terms by breaking them into subproblems. Recursive solution work as a base of dynamic programming, and also in order to solve much complex problems like Tower of Hanoi, in order, pre-order, post-order, tree traversals, and depth for search in graphs, it makes the work simpler. We have to just analyze the logic, define the base case, and we have to write a recursive function in such a way that it moves one step forward towards the solution and ultimately reaches the base case. But when we have to implement this using iteration or using looping statements, it becomes a tedious process and becomes more complex, hence making recursion very much useful. So, what are the steps which we need to follow in order to write a good recursive program? First step while writing a recursive program is to define the base case. A base case is a one which, when encountered by the program, stops the execution of all the other statements. It basically terminates the execution of the program. And the next step is to define a recursive case, which will be encountered if the base case is not encountered. A recursive case must be proper in logic. It must be written in such a way that it will move one step forward towards a required solution, and also it will make an recursive call to the function itself, executing the statements repeatedly and reaching forward towards the solution. The third step is to ensure the recursion terminates. That is, whenever a recursive call is made repetitively, at one point of time, a base case must be encountered and it must terminate the execution. This thing must be ensured in step number 3. And when it comes to step number 4, it's quite simple. We have to combine the base case and the recursive function to make a recursive program, a recursion program. So let us consider a simple example of calculating the sum of n natural numbers. Let us say we'll define the value of n, or we might take it from the user as an input. Our first step will be to define a base case. So whenever we are calculating the sum of natural numbers, adding the sum of 0 is, it does not sound to be a good logic. So we are defining a base case that whenever our iterative value will be 1, we have to return the sum as 1. This will be our base case. So let us assume we have given 5 as an input. We have to find the sum of 5 natural numbers. So we'll be starting from 5. Then we'll go on to 4, 3, 2 and 1. Whenever 1 is encountered, the program, the base case returns 1 and the execution will stop. And later on, all the numbers will get added by backtracking and the result will be shown. So our base case is defined as whenever n will be 1, we have to return 1. So next step is to write a recursive function or a recursive statement which is encountered when the value of n is not 1, which can be defined in simpler terms as for example, let us say we have a function here. It will take the value of n which is given to it, and then it will make a recursive call to the same function by decrementing the value of n. It makes sure that as the process of iteration goes on, the value of our n reaches to 1 and the base case will be encountered. And the recursion basically terminates, which is seen in this process. And the next step is to combine both the solutions, that is our base case and our recursive function. Here we can see the recursive tree how it works. First, the function call will go to sum of 5. The sum of 5 function, what it does is it extracts the value of n, that is 5, and then it makes a recursive call to sum of 4. It extracts the value of 4, makes a recursive call to sum of 3. This extracts the value of 3 and makes a recursive call to sum of 2. And then this function basically extracts the value of 2 and makes the recursive call to 1, which is a base case. 1 is returned. Therefore then we have to do backtracking, which is done by the program itself. We have to calculate 1. Starting from 1, we have to calculate the sum of 1, 2, 3, 4 and 5, and the result is given. A simple code for this is as shown. So basically here we are including the standard input output library for input and output statements. We are defining a function, of the name find sum, which is of type integer. It will take a variable of int n, that is the number until which we have to find the natural sum, and we are defining the base case. If the value of n is 1, here basically we are not assigning, we are declaring. We have to return 1, or else we have a recursive call. We have to return n and make a recursive call to the function find sum of n minus 1. Here is our main function. We are directly defining the value of n to be 5, and then we are printing the sum, and return 0 is a standard way to exit a program. So one thing which I missed is how we can implement this by using recursion also. So yeah, we can implement this by using an iterative approach also as shown. First, initially we designing a function of int sum which takes a variable of int n, and then we have the result which is set to 0. And we're making a for loop iterative statement which increments the value of I and then stores it into the result which was initially declared as 0. Then it will return the result. This might seem very easy process with respect to finding the sum of n natural numbers. But when we take the context of solving a Tower of Hanoi problem, writing the approach using iteration becomes very difficult. So using recursion makes it more efficient and more logical. This is what we discussed previously. So yeah, we were talking about iteration and recursion, and here we have the comparison for both. In iteration, the process of execution might be faster, and in recursion, execution is slower. But implementing a complex program in iteration becomes quite difficult, but whereas in recursion, it becomes quite easier. In recursion, it acquires more memory space because it recursively makes call to the function, but whereas in iteration, the memory occupied is less. But the code size is bigger in iteration, and code is small, simple, and crisp in recursion, full of logic. Debugging is easier when it comes to iteration, but debugging in recursion is quite difficult, but both of them have their own advantages. So we have different types of recursion, that is direct recursion and indirect recursion. As the name itself suggests, direct recursion is a process in which there is one single function and it will call itself. So as we can see here, we have function 1 and we have our base case defined and our recursive function defined. Here the function 1 calls function 1 itself. Making a call to itself is called as direct recursion. As we saw in the problem of finding the sum of n natural numbers, the function makes a call to itself. This is one example of direct recursion. And for an indirect recursion, we have, it is a type of recursion in which we'll be having two functions or more functions, in which one makes the call to the other and the other in turn makes the call to the function which was being called by it initially. This is called as indirect recursion. So here is a simple code implementation, that is a syntax. We have function 1 and we have function 2, and the function 1 makes a call to function 2 and the function 2 makes a call to function 1, and this process keeps on repeating until the base case is encountered. This type of recursion is called as indirect recursion. So this was it about recursion, basic definition and implementation. Thank you everyone.